Hello, everyone. If you want to stand up and stretch, or I know we just had a break, feel free. It's not going to bother me. I feel like some people should be like dancing in the background just to wake up a little bit. But anyway, I want to thank Doug for inviting me to this talk. It's amazing to be a part of this conversation. There's a lot of experienced people in the audience, and I'm not one of them, so I'm hoping to just draw a lot of knowledge from you guys and hopefully make an impact. So what I'm going to talk about today is how to potentially recover a large demographic of plastic that's in the mixed plastic waste stream right now. We've talked a lot about that. I know we've had a lot of depressing points in the conversation that there's not a lot recovery, but this is maybe an opportunity to do that on a large scale. And hopefully in a closed loop fashion-ish. So we know that we generate a lot more than we recover. Mike Biddle already showed this chart. It's an opportunity for us, absolutely. And just a little bit about my background before entirely going into this. Yeah, I didn't start in plastics, right? I didn't start in sustainability. I was obsessed with space and still kind of am. So I was really passionate about that, and also really passionate about the outdoors and nature. And it really, really bothered me to watch single-use disposable containers overflowing trash cans in my town. I know it happens in first world countries and third world countries. These are things like drink cups and takeout containers, and they're just not being recovered right now. So when I looked at this chart from the Environmental Protection Agency, I had a question about how much of it was single-use disposable food and drink containers. And it turns out probably about 40%, that's almost half, of plastic that's not recovered. Don't know how accurate that number is, but I know it's something that varies probably country to country on how much is recovered. But globally, I think this is sort of the picture. So that's about 12 million tons a year in the US that we either landfill or we export as mixed plastic waste. And that costs us about $4 billion in the US to do that landfilling or exporting. So it's pretty significant. So I have a question about why? Why is it not recovered? And the answers I got, talking to people over the last few years as I was doing my research, was that it's hard to sort the polymers. You pretty much have two options. You can go with a very expensive optical device, or you have manual labor. And if you don't have visual cues to pull out things like a water bottle has a visual cue, all the water bottles look the same. If you don't have consistent visual cues, manual labor becomes very difficult. But what I noticed as I used some of this stuff, right, I got yogurt from the supermarket or I had a takeout food container, is that there seemed to be only a few different polymer types that showed up in food grade packaging. And I was just looking at the number on the bottom of each of these containers. It wasn't very hard. So I went to the supermarket and literally picked pretty much everything off the shelf to confirm that there really were only a few plastic types in the mix. And what I found out was, yeah, you pretty much only get 3 flavors of plastic and stuff that is highly not recovered right now, so your takeout containers or drink cups, things like that. And I partnered up with a recycling center that was in my town and said, hey, I want to look in your mixed plastic bales and see how much food grade containers are in there and what the demographic of those different materials are. So we largely get in that mixed plastic bale a bunch of PET, this is all food grade by the way, a bunch of PET, a bunch of polypropylene, and some polystyrene types, right? So the thing about those 3 is that they have very distinct densities. And in order to separate them, you can do it pretty cheaply in just a couple of stages because there's only a few polymers you need to separate. So density-based sorting exists. We're not reinventing the wheel, we're actually just applying it to a very specific problem, the niche of food-grade plastic waste. And what it is, if you guys aren't familiar, is that in the plastics processing that normally happens, you're grinding plastic up generally as your first step. So we grind up the plastic, we drop it in a bathtub of water, and some of it floats based on its plastic type, and some of it sinks. That's a very cheap way to do it. It's very scalable too. And if you do it in multiple stages and have 3 or 4 different water baths, each with a different density liquid, then you can separate the entire demographic of food-grade plastic. In theory, of course, but you can also pull out PLA that maybe ends up in your recycling stream. Let's see. So we wanted to test that this was actually a closed-loop process. So what we want to do is take cups, for example, show that we can recycle, collect them first, recycle them, and turn them back into cups. And we did pilot programs to collect material from Starbucks, from an international airport, and also from the single stream recycling center. We picked just polypropylene for this to prove out the supply chain, so the end market side of it. And this gave us a bunch of different types of grades, sort of polypropylene. We're picking cups from various brands and thin-walled cups and thick-walled cups, anything that showed up in single stream or in those other 2 stores. So we did that, and we recycled it, just toll grind it, toll wash it, and then gave the material to manufacturer and said, hey, turn it back into a cup. If this is not good material, we shouldn't be doing this, right? And they did, and they said it was great material. So that was for polypropylene. When we did go to the airport, this is kind of why I do this, because it was a lot of fun, and I was looking at gray cubicle walls all the time in aerospace. So we brought about 20 volunteers into Denver International Airport, and we asked one of the catering companies, they're the company that puts food on the airline, they also take the trash out. We partnered with them specifically and said, hey, can we dig through your trash? We want to count cups. And they're like, all right, you're weird, but that's cool, go do it. And it was a good opportunity to bring the community in, for one, and also figure out how many cups were coming in per enplanement. We took that one data point, and tried to extrapolate it just to get a sense of what was going on demographically in the US, and also figure out inside the airport, is it difficult or easy to actually collect these things? So we got some good data on that, and I can talk about that afterwards if people are interested. We also knew that if we wanted to make a big impact, that we had to show that we could collect on a large scale. So I already kind of understood that from doing that waste audit, that in the mixed plastic bales, there's a lot of food grade containers. They weren't being diverted into a market. That's starting to change, of course. There's a lot of PET thermoforms that are being optically picked out right now, and some MRFs, the material recovery facilities, that are pulling out polypropylene. But not all of them are, and a couple of years ago, even a very progressive MRF near us was not. So we pitched to them, hey, if you're going to manually sort water bottles into a PET bin, could you also dedicate a cage to food-grade plastic and anything you don't have a market for that you can visually identify as that probably had food or drink in it? Can you put it in our bin? And they did. They tried it. And so we ran the program for about 5 months, large-scale collection. They made a new commodity bale, it was food-grade bales. And we, as part of that pilot, oops, I don't have the slide there, but we, as part of that pilot, also built a proof of concept facility. So we rented a warehouse, we could store that material, where we could also test our density-based method, which you can use existing equipment out there. It's large, it's made for really big processing facilities, so we wanted to see if you could scale it down, make it maybe a little more efficient in terms of how much volume of liquid you were using. So we did that in a proof of concept facility, and that gave us real product samples to then go to manufacturers with, saying, here's the PET thermoform that we're getting out of our process, here's polypro, and the polystyrene. So we're in the middle of that end market testing right now. Like I said, we were able to originally show that the polypropylene is a really good material, and now we're doing PET testing and trying to do kind of a study on whether secondary or tertiary recycling, meaning is the best way to go to close the loop on this material. So the goal is to get it back to food grade quality. So we want that FDA approval stamp ideally on it. We know that that's not super easy to do, but what that means is you can continuously recycle this material and maybe up the percentage of content, of recycled content you have in some of these products, like drink cups. So we're working with companies now that are mission driven and want to see that closed loop solution. And doing some of that testing. So this last graphic is just a reminder that when you do take these items and you do closed loop recycling on them, so you're taking a cup to your consumer, recycling it, turning it back into the cup, you're virtually eliminating your need for natural resources. You're also eliminating the waste on the other end. You're recycling 100% more or less of what you have in that stream, and you're saving your region from a lot of money that's being currently put into landfilling or exporting those things. So then that money turns into revenue locally, which you can use in the manufacturing industry as for jobs. So that's my try. I think it's important that everybody tries, right? We saw a lot of people doing a lot of stuff in talks today, and I applaud that. I think that's wonderful because you need to have more than just a conversation. So we don't know if this is going to end in absolutely successful closed loop solution way. You know, we still have to go through that material testing, but I thought at least I could try. So thank you. If you guys have any questions or want to contact me later, I'll be around and have my card. I appreciate your time.
Any question, Laura?
As I said, I'm from Green Initiative, so we are doing quite similar, trying to do similar projects, trying to do things and projects in China as well. But my question is, how do you get this funded? How do you get the money for this?
So the story is, I work as an engineer and was interested in this, and the way I started it is I cold called a bunch of people to gather information. And it didn't cost me anything but time, and it was a lot of fun. When I started to collect data, I got volunteers, and you'd be surprised at how many people are really interested in solving this problem and think it's really, really cool. And it was great to get them involved. So that cost me almost no money. When I did the pilot with Starbucks, for example, to collect cups, I just walked in and said, hey, I think I have a way to recycle your cups. I'm piloting this in my town. Will you participate in a program if I put a bin in your store? And they said, great. And then I went to Home Depot and bought a $15 bin and slapped a sticker on it. So I think you can do a lot on almost no money if you have the interest, if you have the drive, if that's what you want to do in your day. The pilot facility was the only thing that cost money, really, and we, at that point, had already manufacturers on board interested in, if we were successful, buying our product. And we applied for a grant locally in Colorado that was specifically geared towards developing end markets in recycling. And we said, that's exactly what we're doing. You know, this is what we want you to fund, is a pilot facility where we can actually build some of the technology, test it, bring in material on a large scale. And that is pretty much the only funding we've had so far. Obviously, we want to take it to the next step now, so we're going to be looking for collaborations, partnerships, more cost sharing, and any kind of investment to, if it's really viable with the end market testing, to take it to the next scale.